This lesson is on factorizing a quadratic expression with leading coefficient of 1. This is a quadratic polynomial with leading coefficient of 1. A lot of people know how to factorize such quadratic, but they perhaps don't know why they're using the method that they're using. Let's look at a product. I have here x minus 5 times x plus 3. When multiplying out, we have x times x. That gives us x squared. Then we have negative 5 times x and x times 3. That gives us negative 5x plus 3. Then we get negative 5 times 3. That produces the constant of negative 15. So notice that negative 5x plus 3 when added up results in negative 2x. Therefore, we know that the middle coefficient is the result of two numbers that are added to be negative 2. At the same time, those two numbers are being multiplied to get negative 15. So when you're factoring out a quadratic that has a leading coefficient of 1, you're looking then for two numbers that always multiply to the constant and add up to the middle coefficient. Let's look at some examples. Example 1 is a quadratic polynomial with the leading coefficient of 1. So we are again going to look for two numbers that will multiply to the constant of negative 42 and add up to the middle coefficient of 1. Middle coefficient is 1 because we have x, and naturally the coefficient of x is 1. So let's see what these two numbers are. You don't want to think of what two numbers add up to 1 or subtract to 1 because there are so many possibilities. But we can easily think of two numbers that multiply to negative 42. There are not many possibilities. These two numbers should at the same time add up to 1, and 42, as we all know, is the product of 7 and 6. And one of these numbers has to be a negative because the multiplication is a negative. But since we want the sum to be a positive 1, the smaller should be negative 7 plus negative 6 is 1. And at the same time, 7 times negative 6 is negative 42. So we have our two numbers, x plus 7 and x minus 6. And notice that it does not matter which order you write these factors. I could write x minus 6 first and then x plus 7. Multiplication commutes. A times b is the same as b times a. Here we have another quadratic expression with leading coefficient of 1. The constant is 54. So we are looking for two numbers that multiply to 54. The middle coefficient here is negative 15. We want the two same numbers to add up to negative 15. So again, we don't want to think of first what two numbers add up to negative 15 because there are infinitely many possibilities, but it's easier to think of numbers that multiply to 54. Those two numbers are 9 and 6. And since we want the product to be positive, but the sum to be a negative, both numbers should be negative. -9 plus -6 is -15. And when multiplied, you get 54. So we have the factorization of this quadratic, x minus 9 and x minus 6. You can check this out by foiling out your factorization. And if you get the original quadratic expression, then your calculation was correct. The third example is not exactly a quadratic because the leading exponent is 4. But remember, before applying any factorization method, you're going to look for the GCF of your expression. Your expression could be a polynomial or a non-polynomial, but look for the GCF. The previous two examples did not have a GCF, but here we have coefficients 3, 48, 189. They all seem to be divisible by 3. Well, we know that 48 is divisible by 3 because 48 divided by 3 is 16. How do we know 189 is divisible by 3? There is a cool rule that says if you add up the digits of a number, in this case we have 1 plus 8 plus 9, 1 plus 8 is 9 plus 9, that gives you 18. If the sum of the digits is divisible by 3, and here 18 is divisible by 3, then the number itself is divisible by 3. There is a GCF of 3 for the coefficients. And for the variable parts, we have x to the 4, x cubed, x squared. We take out x with the smallest exponent, that would be x squared. Now, when factoring out, you're going to take each term and divide it by the GCF. 3x to the 4 divided by 3x squared. 3's cancel out. X to the 4 divided by x squared gives you x squared. And we do want an x squared because we want to deal with a quadratic. 48x cubed divided by 3x squared. 48 divided by 3 is 15. And x cubed divided by x squared is x. Use the rule of subtracting exponents. 3 minus 2 is 1, and 1 is the power of x. 189 divided by 3 here is 63. If you're not sure, you can do long division. And x squared is already factored out. X squared divided by x squared gives you 1. So 63 times 1 is 63. Now we're not completely done because this is a quadratic that could be factored out. So we're going to be looking for two numbers that multiply to the constant of 63. And at the same time, the two numbers should add up to 16. And the two numbers are 7 and 9. And thankfully 7 and 9 add up to 16. So we have found our numbers. So in the next step, you're going to carry down the GCF and open the two parentheses and place the two numbers x plus 7, x plus 9. And we are done with factorization of this polynomial. Let's look at the next polynomial. I have to make a minor correction. These should be minuses instead of pluses. All right, so let's see, we have the coefficients of 6, negative 18, negative 108. They're all divisible by 6, so we're going to be taking a 6 out. Now let's see, as a matter of fact, what goes inside the parentheses when you take 6 out. We get 1, which we don't have to write down. 18 divided by 6 is 3. And you can do long division to see that 108 divided by 6 is 18. For the variable part, we have x cubed, x squared, and x. Of course, x with the smallest exponent, in this case x to the 1, is the GCF of those variable parts. And for y squared, y cubed, y to the 4, y with the smallest exponent, in this case y squared, is the GCF. Let's see what happens when we take out xy squared. X cubed y squared divided by xy squared is going to leave you with just x squared. The y squares get cancelled out, and x cubed divided by x is x squared. Then x squared divided by x, that leaves you with x. We have y cubed divided by y squared, leaving you with y. Finally, x squared is already out. Y to the 4 divided by y squared is y squared. And what we have inside the parentheses is a quadratic with leading coefficient of 1. So we're going to be looking at two numbers that multiply to the last coefficient of negative 18 and add up to the middle coefficient of negative 3. Just to get the factors of 18, we have 9 and 2. They do not add up to 3 or negative 3. We have 6 and 3, which seem to work. Since we want the sum to be negative, then 6 should be negative. Negative 6 plus 3 is negative 3. So we have our numbers. We're going to put them in the parentheses, carry down the GCF of 6xy squared, and then inside we have x minus 6y and x plus 3y. Y is needed because the last term has a factor of y squared. Negative 6y times 3y gives us the negative 18y squared.